morning, ladies and gentlemen. My name is Iwan Soenandi from Industrial Engineering Department, Faculty of Engineering and Computer Science in Krida Wacana Christian University, Jakarta. It is a pleasure to me and my team, Nina and Fajar, to share our research with all of you, even only through a video. This time, I will presenting our research with the title Implementation of Backpropagation Artificial Neural Network for Early Detection of Vitamin and Mineral Deficiency. To save the time, let's go to the next slide about the outline. And this is the outline of today's presentation. Ladies and gentlemen, in the next slide I want to show you the motivation of our research. This research was motivated by the fact revealed by basic health research that many of Indonesian peoples lack the consumption of fruit and vegetables. This condition, at the end, can lead to the deficiency of vitamin and mineral. Although seemingly trivial, but this deficiency can cause a variety of diseases that interfere daily activities and productivity for humans. This is some kind of ergonomic problem. Currently, there are several studies on detection of vitamin and mineral deficiencies, including using conventional rule-based and certainty factor. But as we know, these methods has some drawback, like it can be less adaptive and there is difficulty to determine the most dominant type of deficiency. Based on these drawbacks, this research proposed an artificial neural network using backpropagation to make early detection of vitamin and mineral deficiency. Therefore, the problem statement of this research is how to build an adaptive computer system that capable to make early detection of vitamin and mineral deficiency. And the goal is to propose an architecture of artificial neural network to detect vitamin and mineral deficiency with backpropagation. And now, we go to the slide of the methods used in this research. In general, BPN-ANN enable the learning process in the system through weight adjustments to get the most optimal detection result. There are three learning phases of BPN. First phase is the feed-forward phase. In here, the system will receive the input value and calculate the output value according certain formula. The result of this phase will be provided as input for the second phase. The backpropagation of error, and next with the third phase is weight adjustment. Audience can see all the formula with explanation of our paper. The dataset we use in this experiment derived from primary data. We collaborate with some specialists in micronutrient. There are 107 symptoms that use in the input and 17 outputs that reflect the type of vitamin and mineral. There are 118 instances that divided into 88 training data and 30 testing data. We also done some preliminary experiment to get the parameter and hyperparameter value for the architectures, like the learning rate, the number of epochs, error limit, and deactivation function. We use the value that give the best result, or the best result is the smallest error. Finally, for the loss function calculation, we using mean square error. This is the proposed architecture for detecting vitamin and mineral deficiency, with combination of 107, 50, and 17, and in this research, we propose 50 hidden layers. And the table in the right is some examples of the input and output variables. By using the proposed architecture, we run the testing instance and calculate the performance of system using conversion matrix. This table shows the performance testing result for each class output. From all the results, we get the average accuracy is 73%. After conduct the experiment and the performance testing, we can conclude that the preliminary experiment helped us to determine the baseline value for the parameter and hyperparameter used in the proposed architecture. We also can conclude that use of BPN in ANN architecture can help to detect the deficiency in vitamin and mineral with accuracy of 73%. This accuracy obtained using 88 data training and 30 data testing. We realize that this accuracy still can be enhanced, so we recommend to add some data as the training data to produce a better model. We also can use the feature selection methods and done detection according to the selected features only. Hopefully, this strategy can be done in the future to enhance the performance of the system. That's all from my presentation. I hope that we have already done is acceptable and understandable. I would be very glad to have any question, advice, and critiques from audience. Thank you.